Hello everyone, welcome to my channel. Today I would like to talk about the problem of image and image rejection in a receiver architecture. So here, this is a basic diagram of a receiver design. So you can see the signal coming here through an antenna. It goes through an LNA, which stands for low noise amplifier. Then it goes through a mixer. A mixer down converts a signal from an RF frequency to an IF frequency through the help of a local oscillator. And then the down-converted intermediate frequency signal goes into a what we call this channel select filter, but essentially it's a low-pass filter. So as we've covered in my previous video, if you haven't checked it, please click on this link. As we've covered in the previous video, that's the difference between the LO signal and the input signal is the intermediate, the IF signal. So let's say we have in the spectrum, here we have our input signal, let's call it omega in, and here we have our image signal, let's call it omega image. In between the 2 points is where the LO frequency at. So here, keep in mind that the difference between the input and LO should equal to exactly omega IF, and the same as the difference between the image and the LO. Let's say the omega in is a modulated frequency. This is the frequency of our interest, and let's say the image signal has this shape. So the input signal is the one we want, and the image signal is actually undesired. So if you recall from our previous video, when you mix this input with a LO, so what happens here is that on the spectrum, you have, this is the DC point, and this is the omega IF. So what happens is that you are shifting both of them to the center. So what you're getting here is a signal that looks like this. Now, why is this a problem? It is a problem because now you are mixing, now you're sort of superposition, adding together the input signal with the image signal. So in a way, the input signal has already been corrupted by you by adding this whole bunch of things that doesn't belong here. And unfortunately, this process is also irreversible. So once it's done, the damage is done. It cannot be reversed. So what we do is that we would like to, before the mixing action happens here, we want to do some filtering in the input spectrum to attenuate the image signal. So instead of drawing the receiver signal like this, we should add a what we call image rejection filter. Between the LNA and the mixer. So effectively, what this image rejection filter does is that it provides some sort of attenuation or suppression to the undesired image tone here. So if we do that, this tone gets attenuated, and the spectrum, the resulting spectrum would more look like something like this. And here, if you mix the incoming signal with the signal together with the LO, what you will be getting is something look like this. Now here you can see there's still a little bit of an image left, but the amplitude has been significantly attenuated compared to here without a image rejection filter. So there is an important source of confusion here. I'd like to explain what exactly is an image. An image is not really a signal. What we consider an image is that whatever signal that just happens to be appear in this spot, this exact location in the spectrum. Now, what makes this location special is that the difference between the image and the LO equals exactly to the difference between the input frequency and the LO. So in a way, the input frequency and the image are symmetrical. Now you might want to ask, what is the source of these image spurs or signals? You shouldn't be surprised. These images, they can come from many sources. Take 2.6 gig as a frequency, for example. There are many communication devices, technologies, and standards operate around this frequency range, including Wi-Fi, Bluetooth, satellite radio, and many various different type of cellular mobile radio. So you shouldn't feel surprised that some of these technologies, they happen to have spurs that falls exactly in the image frequency of your signal of interest. So in a way, the key here is that the image is not referring to any particular spur. It really is referring to this location, and any spur that falls in this location we consider as image, and we use the image rejection filter to attenuate the image before the mixing happens. And that's why the image rejection filter is typically placed in between the LNA and the mixer.